now being recorded.
Okay, am I audible? Hello, am I audible? Somebody should respond. Okay,
Yes, sir.
okay. So in last lecture, so we have seen this law of gearing, according to which this common normal at point of contact, it has to pass through this pitch point. So common normal to the tooth profile at their point of contact must pass through a fixed point on line of center called the pitch point. This is the law of gearing, or sometimes also called as law for correct gearing or condition for correct gearing. Now let us proceed, and I will take one simple bit as we are in the last lecture, today's last lecture. Now we are going to discuss regarding tooth profiles. So, or in another word, we can call it as a forms of teeth. Right? So basically there are two types of profiles. So what is profile? So this is nothing but the profile. So actually I had planned to take that length of path of contact expression, but again I have changed my plan because we are in the last lecture. So just I will take some of the definitions and the comparison and some part regarding the forms of the teeth. Okay, so there are two types of tooth profile. One is cycloidal and another one is involute tooth profile, right? So this is the involute one. So simultaneously I will draw some of the sketches wherever space is available. So 1 minute. This is involute, and another type, that is the cycloidal. This one is called as a cycloidal. So here I will draw. पहिल्यांदा समजून घ्या. Okay. This one is cycloidal, and this is the involute, right? So we have already seen that two gears are meshing with each other. So this way one tooth, this is the one tooth on this wheel, and this is another tooth on the other wheel. Okay, now these two tooths have to mesh to transmit power from one shaft to the another. Here it is one shaft, here it is another shaft, right? And this way we have seen that power is transmitting, right? Okay, Now for tooth, we can choose any arbitrary shape. So it can be chosen. Suppose for any particular transmission, we have selected this is the one tooth on one gear, right? So this is from first wheel, and suppose we have selected tooth profile for second wheel like this. या दोघांमध्ये मेशिंग होईल का? नाही होणार, right? So whatever tooth profiles that we are going to select for both the wheels should be same. So that those teeth we are going to call it as a conjugate teeth. म्हणजे एका टीथ वर एक tooth or one tooth is having profile like this. So tooth of other wheel should have the same profile, right? Here blue line indicates the line of force, right? So this way that force will be transmitted. So it will rotate like this and it will rotate like this. The same is shown here. This is omega 1 and this one is omega 2. So the involute profile and the cycloidal profile, two types of profile. So now first we are going to check the involute one, how it is generated. Okay, so this is the involute profile. Whatever the shape you are observing here, this is nothing but the involute profile, and this is generated with the help of rack cutter mechanism. So we are having one experiment related to this generation of involute tooth profile. So this part, so just I will make one boundary so that you will understand. This is involute profile, right? Now first of all we'll check what is involute profile. So the definition with respect to this, so already you might have studied in your diploma. So what is involute? It is the locus of point on a straight line, point on a straight line, which roll on the circumference of circle without slipping, right? So this is the point. So this one is the straight line, okay, and this is the first point. Again we rolled this line and we are going to get this second point, then third point, then fourth point, then fifth point, then sixth point. Like this we are going to get the curve, and this profile is nothing but the involute profile. So or other definition you might have heard, the involute of circle, right? It is the curve which is generated by end of cord. एखादी दोरी घेतली आपण इथं आणि याला अशी गुंडाळलेले आहे आणि अनबाउंड करताना आपण ते बाहेर काढताना पहिला पॉइंट मिळाला, इथं डॉट केला, दुसरा पॉइंट मिळाला, इथं डॉट केला, राईट. बाय कीपिंग इट इन स्ट्रेच्ड कंडिशन, टाईट पकडायची आणि नुसती अनबाउंड करायची, आपण बाजूला काढायची, राईट. सो that type of curve is known as involute curve. So whatever this way, इथे पहिला पॉइंट, इथे दुसरा, तिसरा, चौथा, पाचवा, सहावा, right? In this way we are going to get the curve. Right? This is called as the involute curve, involute profile consisting involute curve. Then next type of tooth profile or form, that is nothing but the cycloidal profile, right? So what is definition of that cycloidal profile? Okay, right. So first I will tell definition, then you can check the animation, right? A cycloid is the locus of point on the circumference of circle which rolls without slipping, right? So what you are observing here? Okay, this is the point, this is the point on the circle, and this circle is rolling by rotating in clockwise direction. So like this it is without any slip, right? Now check, right? This point is moving along the curve whatever I have it is generated or I have drawn. Okay, so this circle, for understanding purpose, it is rolling on one straight line or on ground. It is rolling, जिथं स्लिप होत नाही, that is called as a rolling. जसा आपला व्हेकलचा टायर असतो, right? Vehicle is moving in the forward direction because there is pure rolling action. Ground is stationary, and because of rolling of the wheel, vehicle is having different locations. तिथल्या तिथं म्हटलं तर स्लिपिंग एक्सप्रेस होणार, राईट. दॅट्स वाय cycloid is the locus of a point on the circumference of a circle which rolls without slipping. आता इथं स्ट्रेट लाईन दाखवली, त्याच्यावर हे रोल होते सर्कल, and जो कर्व आपल्याला मिळतोय that is nothing but cycloidal profile. आता so whatever you are observing on the slide, right? So a cycloid is a curve or locus of point on the circumference of circle which rolls without slipping. Now this is the piece circle, consider करायचे, this is the piece circle. Otherwise I will draw one figure. Okay, so I will draw one fixed circle like this. Okay, and on this we are going to roll one more circle. it is going to roll in this direction. This is outside of this fixed one, and again we can have another one moving circle inside the fixed pitch circle. One is rotating like this and another is rotating like this. So why I am showing this? So cycloidal curve having two parts. This is also important. Why it is required? Because it is asked in the MCQ type questions. Right. So if circle, so first consider this circle, and this pitch circle is fixed one, and on that it is rolling like this, and in turn we are going to get the curve, and that curve is known as epicycloidal curve. And whatever curve we are getting inside this pitch circle, that is known as hypocycloid curve. That is known as hypocycloid curve. So this cycloidal curve consisting two parts. One is epicycloidal this way, and another one is hypocycloidal, right? So here I can draw for teeth, so you will understand. So this is top of the tooth, this is hypocycloidal, sorry, epicycloidal, and this is hypocycloidal. Okay. This way. And what is involute? So again, for the comparison, I will draw here. This one is involute and this one is cycloid. So what is difference? It consists of single curve and it consists of two types of curve. Okay. This one is face, this is flank, this is face, and this one is the flank. Okay. So you can take next line, or in your notebook you can write comparison between, so directly I will take a comparison between between cycloidal profile and involute tooth profile. Okay. So in the comparison you will understand. So make two sections like this. Here you can write involute and here you can write cycloidal. Okay, involute and cycloidal. So actually, so just I'm writing on the slide. This you are observing in some different handwriting. So actually I will provide you the notes. So just I want to show so that you will get the idea. Okay, these are the scanned notes I will provide. Okay, so this will be provided to you. Okay, this we have seen different materials. Then this we have seen terminology. This is my own handwriting, but on the slide it is somewhat different, so that's why I would like to show this directly, and we'll see the difference. This I have taken. Okay, 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 this way you are going to write. Okay, okay, so write involute gear or involute tooth profile or involute gears, cycloidal tooth profile or cycloidal gears. Okay, okay, so write down first difference. First difference. So just I will shift on the slide. Okay, right here number 1. Then we will write for this number 1. So right here, first difference. The profile of involute gears. Everybody should write the profile of involute gears is single curvature. Is single curvature. Is single curvature, which is involute. Which is involute. Which is involute. Here, in short, you can write here single curvature in bracket. Write down single curvature. Then, with respect to this, you can write with respect to the cycloidal gear or cycloidal profile, you can write the profile of cycloidal gear is the double curvature. That means that profile is having double curvature. Double curvature. That is combination of epicycloidal and hypocycloidal curves. Combination of epicycloidal and hypocycloidal curve. Combination of epicycloidal and hypocycloidal curve. So you can write this epicycloidal and hypocycloidal. Okay, and double curvature. So why I am telling this? because if examination will be based on MCQ type, then just look this, what type of MCQs will be asked. Okay, so already we have discussed this. Then this is the law of gearing. This is the law of gearing. So for visualization, just I will enlarge size. Okay. So law of gearing is satisfied if this is first option, this is second option, this is third option, and this is fourth option. So already we have seen in the morning, common normal at pitch point of contact passes through the pitch point on the line joining the centers of the rotation. Okay, then this is one more MCQs. One more MCQ regarding this involute profile. So involute profile is preferred. Why it is preferred? Why it is preferred? So that answer we can see here. Involute profile is preferred to cycloidal because the profile is easy to cut. Only one curve is required to cut. The rack has straight line profile and hence can cut accurately. And none of this. So what will be the answer? Only curve is required to cut. What you are observing here? Only one curve. Only one curve that is required to be cut. So that's why it is preferred. Okay. So you can write next difference. Right? The line of action with respect to this involute, line of action a line of action or path of contact is straight line. Line of action or path of contact is straight line. Now I will show for involute. This blue line, what it indicates? Path of contact or line of action. कसं nature आहे इथं? Straight line, and that we have written here. The line of action or path of contact is straight line. Then write with respect to this cycloidal gear, second difference. The line of action or path of contact is curvilinear. If available, I will show that. That animation is not there. So based on this slide, right? So there is curve. One is having convex nature. हा भाग वर आल्यासारखं दिसतोय, right? This is convex nature, and another curve, it is having concave nature, right? So that's why whatever path traced by point of contact, it will have curvilinear nature. So with respect to this involute, we are getting here, this is the involute profile. We are getting such path, which one is straight one, right? So this line I have drawn. And in case of cycloidal, instead of this, we are going to get such path of contact, and this is called as a curvilinear. Okay. Next, you can write third difference. Now concentrate here. Third difference with respect to the involute, you can write the pressure angle is constant at each point of contact. The pressure angle is constant at each point of contact. At each point of contact. Each point of contact. Each point of contact. So, and here you can write the pressure angle varies at each point of contact. Varies at each point of contact. Now, what it tells? We will check. Okay. Okay. So here already we have seen twice, thrice, or many times. This is pitch point. This is tangent. And this is line of action. And this angle is nothing but phi. Now check whether it is changing. Change होतोय का? हॅलो, चेंज होतोय का इथं अजय? हॅलो,
No, sir, constant.
yes. So in case of involute tooth profile or gears having involute tooth profile, pressure angle is not going to be changed. इथं दिसतंय आपल्याला, इथून एक लाईन काढले आणि लाईन ऑफ ऍक्शन बदल होतोय का त्याच्यामध्ये? नाही. सो वॉट एव्हर pressure angle, it remains constant. Right. Now, if instead of this, so ह्याचं नेचर आहे स्ट्रेट लाईन, आणि त्याच्याऐवजी जर आपण इथं सायक्लॉइड अज्युम केलं आणि त्या सायक्लॉइड साठी असं नेचर आहे पाथ ऑफ कॉन्टॅक्ट, राईट? इथं इथं काढतो मी दुसरीकडे, एक मिनिट हा. Right? Now, suppose this is the pitch point, right? Pitch point, then for this point, this is pressure angle. For this point, this is pressure angle. For this point, this is the pressure angle. Or okay, for this point, this is the pressure angle. For this point, this is the okay. So this is going to be change for the involute, sorry, for the cycloidal tooth profiles. Okay. Then write down next. Next you can write next difference. Number 4. Number 4. For involute, right? Involute gears are not sensitive to center distance variations, are not sensitive, are not sensitive to center distance variations. Hence, variation in center distance is permitted up to certain limit, up to certain limit to transmit constant velocity ratio, up to certain limit to transmit constant velocity ratio. ऍटलिस्ट तुमच्या लक्षात यायला पाहिजे की एक आस्पेक्ट तरी तुमच्या लक्षात आला पाहिजे. व्हॉट इज हॅपनिंग. So again you can check this. So here if center distance is going to be changed, so I will show next slide. So for this reference, one minute. Center distance variations. Hence, it is not allowed, otherwise it will affect on velocity ratio. It will affect on velocity ratio. Next difference you can write. Next difference you can write for the involute, right? Involute gears are do not have, sorry, do not have interference and problem thereof. Problems thereof. That we are going to study the interference during the interference. And here you can write. So you can take this fifth for the cycloidal. You can write remaining because simple to understand. Manufacture is easy due to single curvature. Manufacturing is not easy due to double curvature. And remaining 2 1. Write this. You can write this. Okay, so right up to this seventh, then remaining part we'll study tomorrow or in tomorrow's lecture. Okay.